Hi, and welcome back to our flipped chemistry classroom. And today, now that we've mastered stoichiometry, we're going to start talking about something called percent yield. And this is really just a way for us to assess how efficiently we are producing a chemical. So we're going to review a little bit of stoichiometry, calculating masses of products from reactants. And we're going to talk about what theoretical yield is, what actual yield is, and we're going to calculate percent yield. So when we talk about percent yield, we're describing how much product was actually made in the lab as a percentage of the amount that could theoretically be made. So percent yield tells us how close we were to making 100% of what we could make. Reactions don't always work perfectly. There's experimental error, there's spills, there's contamination. There's also side reactions that can happen. So both of those often mean that the amount of product that we make in the lab doesn't match the theoretical amount. So it's kind of like if you're making cookies, right? And you look at the recipe and it tells you that the recipe makes 4 dozen cookies. And you know that, maybe you don't clean the bowl perfectly when you get the last little bit of cookie batter out, or maybe your little brother likes to come by and eat some of the cookie dough as you're making it. And so when you go to make the cookies, even though the recipe says that there should be 48, there's only 44. And so when we look at theoretical yield and actual yield is how much is actually made. So that would be the 44 cookies. And theoretical yield is the maximum amount of product that could be formed from the given amounts of reactants. And so that's the 48 cookies that the recipe tells you it's going to make. So when we calculate percent yield, we put actual yield over theoretical yield, and then we multiply by 100. And that gives us our percent yield. So here's our first example. So our chemist has enough materials to produce 75 grams of aspirin. However, he squandered some of the reactants and he actually only made 50 grams. So what was his percent yield? So we're going to have 50 grams, that's the actual, divided by 75 grams, that's the theoretical, times 100%. And we get 66.7%. So now, these are the easy kind of percent yield problems where we're given the actual yield and we're given the theoretical yield. So let's take a look at a couple more like that, recognizing that it's always actual over theoretical times 100. So in my organic chemistry class in college, we were supposed to isolate caffeine from tea leaves. And unfortunately, some of the caffeine got washed down the drain. So I should have yielded 5 grams of caffeine, but I only ended up with 0.040 grams of caffeine at a really bad rate. So what was my percent yield? 0.040 is the actual yield, divided by 5 grams is the theoretical yield, times 100, and I get 0.8%. So that's a really small percent yield. And now we have a case of a student who was isolating sodium chloride, but he didn't wait for it to be dry before he weighed it. This might sound familiar to you all from your separation of a mixture lab at the beginning of the year. So as a result, his product weighed 2.25 grams when the theoretical yield should have been 1.75 grams. So what was his percent yield? Well, 2.25 grams divided by 1.75 grams times 100% equals 129%. It's very unusual to have a percent yield over 100 because most of the time what we have are side reactions or something isn't entirely captured. So most of the time, percent yield is going to be less than 100. When you have issues of contamination, like we have here, where we're weighing water and thinking that it's sodium chloride, then we can get percent yields over 100. Okay, so that's the easy way. We've been given actual, we've been given theoretical. Sometimes you're not going to be given the theoretical. You always have to be given the actual or measure the actual in the lab. So this question is one of those. It asks us, what is the theoretical yield if 5.50 grams of hydrogen react with nitrogen to form ammonia? So initially, this is a stoichiometry problem. We have to find the theoretical yield. So since it's a stoichiometry problem, we know we need to start with a balanced chemical equation. So we're going to put a 3 in front of our hydrogen and a 2 in front of our ammonia in order to balance our chemical equation. Next, we're going to start with our given, which is 5.50 grams. Our unknown is the amount of ammonia, the mass of ammonia. So we're going to convert from grams of hydrogen to moles of hydrogen. And then our next step is always going to be to use our molar ratio to convert from moles of hydrogen to moles of ammonia. And then the last step is to convert from moles of ammonia to grams of ammonia using the molar mass of ammonia. And we get that in theory, we can make 30.9 grams of ammonia. And that's going to be our theoretical yield. However, we only captured 20.4 grams of ammonia in the lab, and we want to know what is our percent yield. So we're going to take this number, that's the actual, the 20.4 grams, and we're going to divide that by the theoretical yield, which is 30.9 grams, multiply it by 100, and we have a 66.0% yield. So we're just adding one more layer of understanding to our stoichiometry. We will always be given actual, or it's something that we'll measure in a lab. We determine theoretical yield from stoichiometry. It's always actual over theoretical times 100%. As always, I look forward to hearing your questions in class, and I will see you soon.